This time, folks, we are going to do a projectile problem, and this one involves deer hunting. I happen to live in the wilds of western Wisconsin, and people actually deer hunt where I live. So here we go. How far does a rifle bullet drop when you shoot a deer 100 yards away, assuming that the rifle is held horizontally and the muzzle velocity of the bullet is 3,000 feet per second? So I'm going to start with a little picture. Here is my intrepid deer hunter. We'll give him a little plaid hat, and there is his rifle. Yeah, there's a reason I did not major in art. Okay, now long ago, far away, here is a deer, and if you go, I don't want anything about deer hunting, pretend this is a big fake target. We're going to put big antlers on this little fellow. And here's the question. When the bullet actually leaves the firearm, it is going to have a muzzle velocity forward, but gravity is also going to make it fall down. And so the bullet is going to go down a little bit, and ooh, I showed a little rise in it. Sorry about that. Trying to make this straight with a little bit of a drop. And I want to know, how big is this drop? What is this change in distance from the straight horizontal downward? Now I know that the deer is 100 yards away, and I know the muzzle velocity of the gun, which happens to be a horizontal velocity, of 3,000 feet per second. Here's how you handle projectile problems. If you have a projectile, always take your horizontal information and your vertical information and put it in two separate columns. So in the horizontal side, I have got a horizontal velocity of 3,000 feet per second. And I know that the bullet is going to have a horizontal displacement of 100 yards. Now I also know in the horizontal direction, the only equation I can use, the only one I can use, is constant velocity is x over t, because in projectile motion, that horizontal velocity is going to be constant. So t is something I can solve for, but let's write down all our information, then we'll go back and solve it. Vertically, I know that when the bullet comes out of the firearm, it is got an original vertical velocity of 0. It just comes right out of the gun. It's not going up, it's not going down, it's going straight out. I do know acceleration of gravity is going to be pulling it downward at 9.8 meters per second squared. And I want to solve for vertical displacement. Now there is a form, this is the way it's typically done in physics, is if you're talking about horizontal motion, you use x, and vertical motion, you use y. If that makes you crazy, don't do it. But I'm going to try and stick to that convention. So I want to know how far is it going to drop due to gravity after it's traveled that far. I don't know time either, but here's one of the things I do know. I know that when the bullet hits the target, it's going to stop moving. So the time in the air is going to be the same for both sides. This is a two-part problem. I'm going to use the horizontal information to solve for time, then use time with this information to solve for y. So let's go about doing that. On this side, time is going to be equal to x divided by horizontal velocity, and I have a challenge. This is feet per second and this is yards. Well, they all have to be the same distance units, so I am going to do a simple conversion. Do you know how many yards are in a feet? How about how many feet are in a yard? Yeah, there are 3 feet in 1 yard, so this is going to be equivalent to 300 feet. So the displacement is 300 feet, the velocity 3,000 feet per second, and I can do this in my head. What's 3 divided by 30? It's 1/10. So the time is going to be 0.10 seconds that the bullet is going to be in the air. Now that I've got that, I can shove that into my vertical information. And if I take a look at these variables, what equation kind of pops out at me? Well, it's going to be x is VOT plus 1/2 AT squared. Original velocity is 0, so this term goes to 0. X, and in this case we're talking vertical motion, so that's going to be y, is going to be 1/2 AT squared. So the displacement is going to be 1/2 times acceleration of gravity, 9.8 meters per second squared, 1/10.1 seconds squared. And when I do the math on that, I get an answer of 0.049 meters. Well, in my brain, that doesn't make any sense. I don't have any sense of what that is, so let's do some conversions. If I convert that into centimeters, that is 4.9 centimeters, and there's about 2.5 inches per centimeter, so that's just about a 2-inch bullet drop. Okay? All right. That is this one, and that will take us to the next one. See you later.